The true breakthrough in artificial intelligence came with the rise of machine learning, a subfield that shifted the focus away from rigid, rule-based programming towards statistical methods and algorithms capable of learning directly from data. Unlike the earlier symbolic AI approaches rooted in explicit human logic and predefined rules, machine learning empowered systems to identify patterns and improve their performance over time by adapting to new information. This marked a fundamental shift. Rather than being explicitly programmed to perform every task, machines could now learn from examples and experience. During the 1990s and early 2000s, rapid advancements in computing power and the development of more sophisticated algorithms laid the groundwork for this transformation. Improvements in hardware, combined with the increasing availability of digital data, enabled AI systems to tackle more complex problems. Early achievements during this era included speech recognition programs capable of understanding natural language with increasing accuracy, chess engines that could challenge and even defeat world champions, and algorithms designed to solve intricate mathematical and logical puzzles. These milestones demonstrated that AI was moving beyond theory into practical, impactful applications. However, it was not until the 2010s that AI truly began to accelerate at an unprecedented pace, driven largely by the emergence of deep learning. Deep learning, a specialized branch of machine learning, involves the use of neural networks with multiple interconnected layers, hence the term deep, to process and analyze vast amounts of unstructured data, such as images, text, audio, and video. Unlike traditional algorithms that required carefully engineered features, deep learning models excelled at automatically discovering intricate patterns and representations within raw data. This capability unlocked new possibilities, allowing AI systems to perform tasks once thought to be uniquely human, such as recognizing faces in photographs, understanding spoken language with remarkable nuance, translating between languages, and even generating coherent text or realistic images. The success of deep learning was fueled by several factors. The exponential growth in data generated by the internet and digital devices, advances in parallel computing using powerful GPUs, and novel algorithmic techniques that improve training efficiency and accuracy. These innovations not only revitalized AI research, but also led to widespread real-world applications across industries, from healthcare and autonomous vehicles to finance, entertainment, and beyond. In essence, the advent of machine learning and the subsequent revolution of deep learning transformed AI from a largely theoretical pursuit into a dynamic, rapidly evolving field with profound implications for society. This new era of AI has opened doors to innovations that were once the realm of science fiction, continually pushing the boundaries of what machines can achieve and reshaping our interaction with technology.